And indeed, it goes, does the work, and it does pass it. So now I peek behind the curtain just to see what it did. And it basically, it just added up all three values. Nothing to write home about. But now we have a system that's working. We have grand total that's passing. Okay, this is the from barren terrain to your like really just some little shrubs and grass, nothing spectacular. Now we move into the next iteration. So this is permaculture by succession. Now we say, okay, let's now elaborate a little bit. That's fine, okay, we have the total of items, we have sales tax, we have tariffs. What about order discounts? It's a very realistic scenario where orders may come up with discounts. Okay, fine. Now we move again into the 3 C's. Card says calculate your grand total with a discount. So now we are incrementing, edging towards a more comprehensive order e-commerce system. Now from that card we go into conversation. We say, okay, we should first calculate the grand total, order total, including all order items, sales tax, and tariffs. And then we should then deduct order discount, if any, from the grand total. Okay, that makes sense. Everybody agrees. Let's produce the confirmation example. And we go, given that the order items total up to $100, sales tax is $5, tariffs are $20, and discount is $10, we're expecting the grand total to be $115. Okay. Now we present to the Genie, I call it Genie or AI agent, however you call it. We say, look, here's the next iteration, here are 3 C's, and please read through that, refactor the tests, and make sure the new test fails. So this is what it does. It refactors the existing test, it creates a new test. It expects 115 here, over there it still expects 125. And then I look at the initial implementation, slightly refactored, but still no discount logic. So we're taking tiny steps, patient. We run tests, and now we see that one passed, one failed. The one that failed was expecting 115, it got still 125. So still, we have a broken system. So now we change the AI to, we ask the AI to change the code to make all tests pass. It does that, and we see that it had created total before discount, so it's smart. This is all the AI did, I didn't do anything. And then it subtracts discount. Now both tests pass. And it can tell us what it did. And it's very useful here. It says, look, I have, you gave me one test suite. It passed successfully. There were 2 tests in there, it passed. We have successfully completed the red and green cycle. The red is when it fails, green is when it passes. It says, now it knows that I go into the refactor phase, and it describes, I've introduced total before discount variable, keep the logic clear, then readable. Code is clean, and in both cases, no duplication, no further refactoring is necessary. The system is stable and robust. I'm ready for the next test. Beautiful, smart, music to my ears. So next iteration. Now we keep growing our system. This is a permaculture by succession. Okay, so we introduced our discount. We just slammed $10. Where are these $10 coming from? We just pulled it out of thin air. There's got to be some business policy rule that is governing the calculation of the order discount. On to the next 3C, with carbon, etc. So we can go with the whole night about this, we can grow as a system, but the point is, it should be obvious even from this toy-sized example, how important it is to keep our AI assistants on the straight and narrow path. We really constrain, put the harness on them, and we really instruct them to just fail or pass. It's binary, right? No room for hallucination, for pulling all these fancy things into the works. So Ken Beck, people probably heard of Ken Beck, he's one of the great guys. He says, using Genius, he's calling AI assistant Genius. He says, using Genius for coding is mostly inhibition, getting it not to do harmful stuff. Prompting looks like you're trying to get the Genius to do something, but that's an illusion. Sometimes you do, but more often you're saying, not that, less like that. Do this other thing first. Like reining in a horse that wants to run. And that's exactly my feeling when developing software. We need to find the discipline, the way to keep it really constrained, and then it's phenomenally useful. So trying to stay within the realm of tiny steps, that's a big challenge. We all rush and we want to quickly deliver the whole demo and impress the clients, etc. Also, notice how throughout this exercise, we never let the code not be working. How so? Any minor change, we run tests, we run all tests. We don't pick and choose tests. So the code is always working. The system is always in operational state. So what are the key takeaways that I want to share with you tonight? First, I think that AI at this point is well suited for labor. The mechanical task of refactoring, which we've seen is tedious for humans and just takes a lot of time, risky, and demoralizing. So why is AI suited for labor? Number one, total context awareness. AI can hold the entire code base in its mind at once. It doesn't forget about that obscure helper function somebody wrote 3 months ago. When AI refactors a component, it can instantly trace and update all its dependencies across the entire project, which is something that is tedious and error-prone for us humans. Number two, speed and consistency. AI can perform a complex project-wide refactoring, like renaming a core variable or restructuring a data model, in seconds, not hours. You will do it with perfect consistency, applying the same patterns everywhere. Number three, elimination of fatigue and bias. AI does not get tired. Doesn't take bathroom breaks, doesn't take shortcuts, doesn't have a favorite way of doing things that might be suboptimal. It will refactor based on established principles of good design. It knows about solid, dry, all these first principles, very well informed about them, knows how to use them, and there's no ego or fatigue. And lastly, self-documentation. AI can refactor the code, simultaneously explain exactly what it did and why, providing a perfect commit message or documentation of the change. We've seen when it explains itself, how it introduced a new variable, clear the logic, etc. No code duplication. It knows all about these things. What AI cannot do, on the flip side, I find that it cannot do why and when. It is not well suited for strategy, at least in my opinion. Maybe somebody disagrees, let me know. Strategic architectural decisions, AI can refactor a component to be cleaner, but we are the ones who decide if that component should even exist. It's on us. Should we break this part of the app out into microservices? Is our current state management library going to scale for the next 2 years of planned features? These are high-level architectural decisions that AI can help execute, but we must make. Identifying code smells with business context. We might look at the piece of code and say, this is getting too complex because our business rules for shipping have become a mess. AI might see the complexity, but it doesn't understand the business reason for it. We can provide a crucial instruction. The calculate shipping function is doing too much. Refactor it to separate modules for domestic, international, and freight shipping. Because we plan to add more shipping partners next quarter. AI doesn't know that. It's us. The bus factor and human readability. What if we need to bring another human developer into the project? What if we want to sell the company or open source the code? The code must remain intelligible and maintainable by humans. While AI can write clean code, we are the ultimate judge of its clarity and elegance from a human perspective. We are the quality assurance for human-centered design. performance and cost optimization. We might know from experience that a certain clean abstraction that AI creates will have unacceptable performance implications under heavy load, or that using a particular pattern will lead to higher cloud service bills. Our real-world experience is the guardrail against AI's theoretically pure but practically flawed solutions. So we must remain on top, right? So here's the proposed human-AI collaboration model for me today. This may change, but where we're at this point and with my current experience, the human, which I call the architect and navigator, periodically review the overall structure of the app. Navigators, us, spot an area that's becoming a bottleneck or is getting hard to reason about. So we give a high-level directive. For example, the user management components are getting tightly coupled. Let's refactor them to use a centralized state management store and make the components dumber. Or, I don't like how we're handling API calls. Can you refactor all GET requests into a single reusable API service with built-in error handling? So this is our directive, right? On the other side, the AI, or what I call implementer or driver. AI or driver proposes a plan for refactoring, executes the refactoring across the entire code base, then presents the diff, or a summary of changes, to the navigators, to us, for our approval. We review the changes at the strategic level, and ensuring that they meet our architectural goals, and then we approve and merge. So that would be the collaboration model. I call it test-driven navigation. You're navigating, but navigating via tests, or TDM. As if we need more acronyms. So the roles are now split into a navigator and a driver. The navigator, chief architect, provides the strategic direction, while the driver takes on the responsibility of fulfilling the directions by driving as instructed and making sure that the vehicle or the system is in perfect operable condition at all times. And how do we know it's in perfect operable condition at all times? We run tests. All tests must be green. That's the only way for us to know. Don't take its word for it on the tests. Is this the end of tedious manual code review? Sometimes people ask, because we give free reins to the driver, all tests are passed, do we need to review the code? What do you think? I would say that in the test-driven navigation workflow, writing the next test is the code review. So what do I mean by that? Let's say we have grown this system and it's getting very elaborate e-commerce order process. Run our test, everything's green, everything's looking cool. We assume that the code is at a high level. Suppose we introduce the new test, next test. We see it fail, we tell the AI, okay, now make it pass. And the AI cannot make it pass. Now that's a code smell, right? Now, we recognize that something went wrong. And this is the red flag for us to say, okay, I need to intervene, I need to jump in, I need to review the architecture, I need to review the design. Where have we taken the wrong turn? You should be able to pass the next test. That, to me, is the code review. Can you pass the next test or not? Because we are reviewing the system's behavior, not its implementation. And that frees the developers from the chore of line-by-line review to focus on architectural direction. So in conclusion, I think we should not need to worry about the line-by-line structure of what AI creates, the code output, as long as it works. And how do we know it works? With all tests passing. But we should absolutely worry about the design and structure of the code at an architectural level. Our skill in refactoring is not obsolete. It's being leveraged. We graduated from being the mechanic who tunes the engine of the race to the race engineer who decides on the overall car setup for the win. We focus on the blueprint, AI focuses on laying the bricks perfectly. This is a more powerful and fulfilling way to build software. We are free to focus on the truly creative and strategic challenges that define a great product. It's more delivering value. AI does not diminish the craft, it refines it. We are not coding monkeys, we are architects. And this is what I mean by making a shift from implementation up to the specification. And again, I'm gonna quote Steve Jobs, who said, it's not just what it looks like and it feels like, design it how it works. And my parting message is, keep your AI on a short leash. Okay, so let's see if I have any questions.
I want to answer the question, Alex. Is TDN your invention in contrast to DDD? Because this is really very powerful, what we just actually described today. This is the right way of writing software using augmented with AI. So the test-driven navigation, is that yours?
Yeah. Because I'm always into test-driven, so it was close to mine. Yeah, I'm big on test-driven development, but navigation, like Xander says, is a bit higher than just developing. When navigating, we have a trusted, powerful planetary brain called LLM, whatever you call it, that can hold a tremendous complexity at once in its brain, which I can't, and then it doesn't make mistakes at that level, but it's not sentient. It has no purpose. It cannot understand why I decided I want to go this way or that way. That's not its job. So I think we should take on that responsibility. And if there are some people here who are inspired to say, well, I want to do software development now, the real trick here is to learn how to decompose whatever business domain, decompose it into small steps. That is the hardest part. If you can do that, then you can create fantastic software by following this, navigating. But at every step of the way, you need to see that everything is working. And the smaller the step you take, the more solid and reliable and confident you are. So it really is breaking down, or Andre and I talked previously about vertical user story slicing. It has to be narrow. It has to be, we've seen the 3 C's. You have a simple card, you have a simple conversation. You come up with a simple confirmation example, and then from that example, when the system implements it, you're now growing your system by making the concrete more generic. Every step of the, yeah, go ahead.
I find very interesting when you mention about AI is not ready for architecture, right?
But my experience, maybe it is.
No, I don't agree. But my point is, do you think that you'll never be, because maybe I think there are 2 parts to that problem. Again, I'm not saying this, I like your point, because I never thought about that, right? Is that, one, is that it has to do with context, how much context AI can hold. That's one technical problem, let's say. The second one is that there is a quote that I don't know who's the real author that says, sorry I wrote you such a long letter, I didn't have enough time. We are bad at summarizing things. And when you need architecture, as you mentioned, is a lot of information. We suck at condensing that and passing to the AI. That's the challenge.
Yeah, I
what
agree.
are your thoughts on that?
I agree. Again, and I think I spoke with Andre about that, and he corrected me, but I will say it nevertheless. And I know you're going to correct. In my opinion, we have trained AR on the finished products. So we showed, here's the repository quality code, and it learns from it by looking at completely finished product, and finished poem, finished movie. So these are all like delivered, finished things. But I'm not sure, or it doesn't feel to me like we've trained it on the process, from starting from something like really innocuous, small, and how it grows to become a finished product. So I don't think it's aware of that. And that's why I'm trying to backtrack and say, okay, don't do everything in one big bang. Let's take it step at a time and slowly grow it. So, but there are 2 schools of thoughts. One is from the ground up, the other one is from top down, right? In the waterfall world, we start with the grandiose vision, and then we go break it down into components until we go down to the line of code. This is almost like the other way around.
Yeah, and I think it has to do with that, right? Because the big picture, we imagine the amount of information. You're just trying to summarize. That I think works so well what you described, that it's much easier to express that small unit of work. then hey, this is everything. Think about when you're discussing architecture, right? You're always going to have, oh, but what about this scenario? Yeah, but I didn't talk about this, but yeah, it's included here on this scenario. The result is kind of like, because all the information would be required to pass to an AI for it to operate at that level, it's a lot. And even for us to consolidate that would be a lot. I don't know.
Sure, but that, again, if I understood you correctly.
All that to say this, I don't think that's impossible.
Mm-hmm.
I just think first there's the context window kind of problem that AI can hold. And second is we need to, it's a lot of stuff for us to pass along to the AI so we could actually test, okay, are you capable or not to do that? Or think about the information you give to AI to create an architecture. If you pass to a human, do you think the human, without starting to making assumptions, would be able to do it?
No, I mean, I think it's capable of doing this, but the issue is this. The work presents itself once we start working. And the quote from Rumi says that the action, there's no clarity before we start acting. If we're sitting in an ivory tower and we're daydreaming and we have this vision and all that, that's not action. That's pretending we have a crystal ball and pretending we can see the future and pretending we understand exactly what the architecture should look like come November this year. But if we start working and navigating the waters, no plan survives the first contact with the enemy. So that's where the issue is, that we need to work step by step. As we work, the work presents itself, and we realize, oh crap, I need to. It's like the difference between a roadmap and the sea chart. On the roadmap, we can go right from here to Calgary, and you know exactly how. If you're in a sailboat and you want to go somewhere, you never know how the winds are gonna. So your path will be like this, right? Eventually you get there, but you have to be in the moment, and you have to respond to whatever is happening right now. This is the thing with software and trying to model complex, unfathomable business world, which is the VUCA world, volatile, uncertain, complex, and ambiguous. So that's why I discovered this to me to be the most confident way to move forward. And also I think it opens the door to many other people who have maybe thought, software solves it, too complicated. No, leave that piddly stuff low level to the AI, and you assume your navigator position, and you start giving directions, but you need to break it out to smaller steps. Sorry, am I encroaching on the time? Or
our timekeeper actually left, so we got another couple of minutes. So yeah, we have more questions.
So would it help to have like a TD-driven vibe coding tool that we can build?
What do you mean, tool?
A TDD-driven vibe coding tool, like renderer, except TD-driven. So that would basically be smaller steps and bring them. So
yeah, but there's nothing in TDD that will force.
Well, just a test-driven aspect of it, but that will allow you to break it into smaller steps.
The breakage into smaller steps is not the job of the tool, it's the job of the thinking person. There's no tool that will force me to break things into smaller steps. I have to break them. And then I can use the tool to keep going. Maybe there is, but I have never discovered a tool that will force me to break the problem into smaller steps. Does that make sense?
Yes, but the whole aspect of it is to go away from having to code yourself and getting the AI to code, a genie to code for you, right?
Yeah.
If we are writing the initial test, then we basically require software developers to write the test and give the struct and everything like that.
Ideally, if we know how to write good tests, like when right now I'm developing a lot of software, and I find that I write a lot of tests, and those tests pass. I now rarely go and actually look at the code. I'm at this point. Maybe it's a dangerous situation, but I'm like, look, if all my tests are green, but why do I have to spend time looking at the code? I think it knows how to pass those tests, and also I'm also doing the post commit GitHub hooks where I actually specify the refactor.md document, and I put best practices and code examples. And I say, okay, every time you do this, check this and make sure it's dry, it's solid, it doesn't have code duplication, the cyclomatic complexity is below 10. There's all this, you can put the bar for your quality. And the Genie will, and you can say, make this reliable, meet this bar, make sure that cyclomatic, make sure that, coupling is low, make sure the cyclomatic complexity is low, etc., etc. You can, you as a navigator, you dictate the bar, you dictate the quality, right? And then it must meet that. It is your servant, right? You will not agree on anything less than that, right? But again, I find that the biggest challenge is taking those small steps, not rushing, not overreaching.
I think we could spend another couple of hours here discussing. That's actually very, very powerful, Alex. Thank you very much. This was great. So our speakers are still here. So if you would like to actually talk to them, then we got a couple of minutes. But before that, yeah, raffle. There we go.
Everybody put their tickets. Somebody? No.
Okay.
Yeah. Okay, the winner is 41570841.
Allocation 0.
I'll repeat 41570841. Okay? 1, 2, 3, okay, we have a new number 415-71078. Oh. No one? Okay. Next number 415-70849.
The number is too long.
Ending with anyone 849? Okay, maybe this one is lucky. 415-71082. Yeah! All right. No, this one.
All right.
Congratulations.
Oh, thank you. This is going to be good. I'm going to be able to post this, right? Super.
Yeah,
Thank you.
Okay, thank you very much everyone for coming today. If you would like to speak, we've got already a couple of people actually lined up, but please actually reach out to us and we will be hosting you in one of the history classes. Thank you very much everyone.
Thank you so much.
Sorry about that.